So for this one, you notice an instructor tip should pop up. It reads, and this is what instructor tips are ones that I put in personally. I say I recommend copying the table down on paper, use the calculator to find the totals for the rows and columns, and then use the calculator to determine the probabilities. Okay, so let's close that out. And let's read what it says. It says, the data in the following table shows the association between cigar smoking and death from cancer from 136,479 men. Note, current cigar smoker means cigar smoker at the time of death. Let's look at the table. There we go. Now, it does have a way to open this up in StatCrunch or Excel. StatCrunch is not super easy at showing you how to find these totals, so we're just going to copy this down on paper real quick, and then we will find totals with the calculator. Okay, so here's our table. I went ahead and sort of prettied it up. You did not want to see my handwritten table written out, so I typed it up in Word. And there we go. So all I did was I added up 589 plus 121,231, and I got my total for those who never smoke cigars. I did the same for each row, and then I did the same for each column. You sometimes will have that given to you, and sometimes you'll need to do it yourself. So part A reads, if an individual is randomly selected from this study, what is the probability that he died from cancer? So here, I'm not even asking about if they smoked or not. I'm just saying, did they die from cancer? So I look at the number of successful outcomes. In this case, the success is dying from cancer, which is 792, and I divide that by the total, 136,479. Let's look and see what my StatLab wants, 3 decimal places, because that fraction doesn't really mean much to me. I want this in terms of decimals. And I get 0.006. And again, if they're going to give you 3 decimals every single time, you can change your mode. Press mode, and I've got mine on not float. Float would give me all the decimals. I've got it at 3. Okay, part B, if an individual is randomly selected from this study, what is the probability that he was a current cigar smoker? So again, find the number of successful outcomes. Remember that success is sort of what we're looking for. In this case, we're looking for current cigar smokers. So just count that. It's 6,012. So 6,012 divided by the total, 136,479. Give it around into 3 places and see what we get. And when I put that in, I get 0.044. Okay, so now if an individual is randomly selected, what is the probability that he died from cancer and was a current cigar smoker? So how many died from cancer and were a current cigar smoker? So it's the intersection of these 2 columns. So we have a total number of 147 divided by the total, 136,479. And we get 0.001. Okay, if an individual is randomly selected from this study, what is the probability that he died from cancer or was a current cigar smoker? So it's a little bit different, right? Because here, the first one, part C, was looking for and. Now we're looking for the or. So we're going to be adding some stuff up, right? Because ors we typically add without double counting. So die from cancer, that total, we would add all these up, and it's already been done for us. We have 792, or was a current cigar smoker, so we would add these up. Except I've double counted, right? I've already added up the 147 twice. So I could just add up the 5865, or I could add the 6,012 and then subtract back out the 147, which would give me the 5865. It doesn't really matter which way you go. It's the same calculation. So here you can see I've gone ahead and added the 792, the total for the died from cancer, and then added that to the total who are current cigar smokers, and then I subtracted out the intersection. That kind of goes along with my formula, right? The probability of A plus the probability of B minus the intersection. And I get, when I divide by the total of 136,479, I get 0.049. Okay, well, I hope that helps.